Okay, and hi everyone. Thank you for joining us again for another session of JNation Online 2021. Unfortunately, this year we have to do it virtually. We cannot do it physically, but maybe we can do it next year. And here with us, I have Graeme. Hey, Graeme, how's it going?
Hello, nice to be here. Thanks for the invite.
I mean, it's a really pleasure to have you here. As I was saying, we would love to have you here with us in Portugal. Are you still in Spain, by the way?
Yes, I live in the north
Yeah,
of Spain, in
yeah.
the Basque region, so it's probably even drivable.
Yeah,
And
it is drivable. So
yeah,
I mean,
so
you're very, very close to us. So it will be awesome for you to come. But
yeah,
for now, we cannot do that. So maybe next year we can do the event physically, and then you can just take like a couple of hours drive and meet us physically. Um, yeah. Anyway, I don't want to steal your time. I know that you have a lot of things to cover and lots of things to show us. Very, very exciting things. If anyone wants to post any questions to Graeme, please let me know over Slack or on a YouTube chat. I'll be happily relay that back to Graeme. So Graeme, I know they're going to talk us about Micronaut and GraalVM, a couple of new technologies. Well, GraalVM is already a couple of years old, so Micronaut's a little bit newer, but it's really an awesome thing. So feel free to take the spot and begin the presentation.
thank you. Actually, Micronaut actually predates GraalVM by 2 months.
Oh,
Um,
was that so? Okay.
yeah, we had no idea it existed before we built Micronaut. We kind of went on the plan, but anyway, I'll talk about that in my talk.
Yeah.
So let's
Sorry about that. I'm mixing dates then.
no, that's fine. It's nobody can have the life cycle of every framework in their head.
Yeah.
That's impossible to achieve. Okay, so I'm going to share my screen and we can get started with the talk. Okay, so introduction to Micronaut and GraalVM. So thanks for everybody who is attending. For those of you who don't know me, my name is Graeme Rocher, and I am the creator of a couple of well-known frameworks in the Java ecosystem. So one of them is Micronaut, which is the subject of this talk. Another is Grails, which is a little bit older, but much used and much loved framework. I'm currently working as an architect at Oracle Labs, which means I work on the same team as the GraalVM team and all the native image guys, and we work together closely on integrating Micronaut and GraalVM together. A bunch of other things, and if you want to connect with me on social, you can do so with those links below. I'm happy to answer any questions via that avenue as well. If you have them, do feel free to reach out. So on the agenda for today, we'll go through the background that led to Micronaut. We'll go through an introduction to Micronaut, and we'll go to an introduction to GraalVM, and we'll talk about how the two of them work really well together, and we'll do lots of demos, live coding, and hopefully have some fun. So let's get going. Okay, so in terms of what led to Micronaut is the evolution of the way applications are architected. So traditional applications in the Java ecosystem have typically run in a single Java virtual machine on a container, a Java EE container or a Jakarta EE container, as they are now. And that gives the applications a fair amount of opportunity to share memory and resources across the different applications. So the deployment unit would be like a WAR file, for example. And they will all be running on the same essential Java virtual machine. And more, as we move to the cloud and cloud architectures, instead, we have this arrangement where applications are essentially running sometimes in containers, sometimes not, but generally orchestrated by a cloud and running in individual JVMs, where you have some apps that are like microservices, some apps that are streaming applications, some apps that are serverless functions, serving different purposes, orchestrated by something, maybe Kubernetes, maybe not, who knows what you're using, and running in these kind of individual Java virtual machines. And this then leads to essentially difficulties of dealing with that at scale, because with a lot of traditional frameworks, when you compare it to something like Go or other languages that are able to compute into native applications and consume less memory, that it leads to essentially greater use of memory, because traditional application frameworks such as Spring, etc., make extensive use of techniques that are generally bad for memory consumption and startup performance. So things like reflection, runtime bytecode generation, runtime generated proxies, dynamic class loading, and so forth. All of these techniques lead to longer startup, more memory consumption, and it's pretty much the reason why all of these techniques are avoided on, for example, mobile. In the Android community, none of these techniques are used because they lead to greater use of resources, which is unacceptable on a mobile. But on the server side, we still, essentially put up with these things because that's just the way historically applications have been written prior to things like Micronaut coming along. So, and my reality is, in general, we've been trying to fit repurpose frameworks, existing frameworks that are based on reflection and so forth and really that were designed at a time when deploying to Jakarta E containers was a thing and so forth, into this new paradigm of individual runnable jar files and individual microservices and so forth. And really, the elephant in the room is that they don't essentially fit that paradigm that well because they were never designed for it. So in general, what you've seen is you can obviously turn a lot of these features off or switch to a different framework. So a lot of people have, for example, switched to these micro frameworks, things like Vertex, where you programmatically do everything instead of using the kind of annotation-based programming model that Java developers love and have become productive with. People have tried to switch to things like that, but then the drop off in productivity when you switch to hand rolling everything is massive. People are used to having frameworks that have kind of batteries included out of the box and lots of productivity features, and that's where we have this correlation in terms of in traditional applications where you have the number of lines of code in your app and the startup time essentially increasing. So we wanted to kind of address this challenge and make more efficient applications. When we started planning and designing Micronaut, we did a lot of profiling and looking at the performance of Spring and Grails and existing application architectures and finding bottlenecks and so forth, and analyzing where all the memory consumption was going. And the result of that was pretty much universal across traditional frameworks. It's not based on the tools that Java provides us. So Java provides two traditional frameworks, a kind of annotation API that lets you get annotations from the reflective metadata, but it doesn't really let you, for example, do things like scan for the inherited metadata or process meta annotations automatically, where you have an annotation on another annotation. So a lot of frameworks have essentially had to kind of build those abstraction layers over the annotation API. Then you have things like type erasure, with Java essentially erasing generics at runtime. Again, there's literally thousands of lines of code in a lot of frameworks to deal with the fact that type erasure happens. Also, reflection, dealing with the kind of relative slowness of it, has been a trend in framework design and tool design in general. You've seen an evolution from early days of libraries like cglib, which did bytecode generation at runtime, to improve the performance of reflection, then evolving further into Java Assist, doing the same thing, and then more recently ByteBuddy, allowing essentially invocations and so forth. So to address the slow reflection problem, and there's other efforts as well at the kind of JVM level with method handles and invoke dynamic. but in general, having to deal with the performance of reflection is a trend that all frameworks have had to deal with. And the other thing was like proliferation of like reflective data caches. So a lot of traditional frameworks are made up of something like Spring, something like Hibernate, something like Jackson, and each of those does its own reflection and stores its own caches of reflective data. Instead of there being a single meta model for all those different toolkits, they each create their own meta models, which leads to higher memory consumption once again. Class path scanning as well. Traditional frameworks based on scanning the bytecode and looking for annotations have traditionally been slow. And finally, like dynamic class loading. So a lot of applications that are based on like this servlet environment, for example, where you have to support redeploying, have very dynamic class loading architectures where that account for the fact that you need to redeploy. Whilst with modern applications where you're essentially using an orchestration or container orchestration infrastructure, you often don't need to redeploy in that manner. So having all this dynamic class loading behavior is kind of like just wasteful. So with Micronaut, we focused heavily on elimination of reflection. And much the way that it's been eliminated in mobile frameworks like on Android and so forth. Often get asked, why is reflection the problem? And the fundamental reason for it is reflected data is kind of an all or nothing affair. Once you access any of it, you kind of get everything. So reflective data is initialized when you first access and held in soft references that are not GC'd until your application is like low on memory. Every field, method, etc., gets initialized into the reflective data cache of the class. And if you have like a lot of code in your class, that can be very expensive and occupy a lot of memory over time. So traditional Spring application, for example, often has to allocate a significant amount of memory just for reflective data. So with Micronaut, what we did was we kind of re-looked at this architecture and saw what we could do to essentially move a lot of the way frameworks work into the Java compiler. So Micronaut is, obviously primarily focused on microservices and serverless, but you can also build any kind of application with it. So if it has a static void main, you can use it. The way it works is it's an annotation processor. So it hooks into the Java-C compiler and essentially will compute the way the framework needs to work at build time instead of waiting till runtime to figure everything out. And it's basically the results of all lessons learned building Spring and Grails applications over the years. So you can think of Micronaut as kind of a build-time framework infrastructure. So it'll do all dependency injection at build time. It'll do configuration injection. It'll compute annotation metadata. It will do any kind of proxies that are needed for the application are computed at build time, rather than waiting for runtime and using something like ByteBuddy, like traditional frameworks use. And it supports things like, for example, bean introspections at build time, such that you can essentially serialize and deserialize JSON without using reflection. And it's completely reflection, runtime proxy, and dynamic class loader free in general. So with Micronaut, you can build a whole range of things. You can build microservices, you can build serverless applications, you can build message-driven applications with one of the supported messaging systems. So we support Kafka, Rabbit, JMS, MQTT, lots of different messaging systems. You can build command line applications. You can even build Android applications. It is running on Android as well. And it's very suitable for Android because of its build time DI nature. And it's pretty much anything that has a static void main And we've written compiler plugins for 3 languages. So you can use Java, Kotlin, and Ruby to build applications. And Micronaut, since it's announced, was announced in March 2018, has had a significant impact on the industry in terms of the way framework design is looked at, even outside of Java. So in the ASP.NET space, they have looked at the way Micronaut works and moved more things into the build time process. And other frameworks like Quarkus have moved to using build time approaches based on similar approaches to which Micronaut took back in 2018. Micronaut has really changed the face of server-side Java in terms of what people expect in terms of performance and startup from applications, and is really leading the way in terms of build time solutions. Closely related to Micronaut, and actually shortly after Micronaut was first announced, another technology called GraalVM out of Oracle Labs was announced. And when GraalVM was announced, it had this ability to produce native binaries from Java code. And we were like, oh wow, this GraalVM can produce native binaries from Java code. So what's the requirements to do that? And what it does is like a closed world static analysis on your Java code. And because it's a static analysis process, it needs to be able to statically reach all of your code. So that means, if the application does any reflection or runtime dynamic class loading or anything dynamic, all of those things need to be declared up front. And we were like, wow, Micronaut doesn't do any of those things. This is a perfect fit. And ever since then, Micronaut has been seamlessly working with GraalVM Native Image across releases and integrating really well with it. So as Native Image has evolved and improved over time, Micronaut has evolved with it and really improved, and it's really one of the best frameworks that you can use to build native applications with GraalVM today. And but GraalVM is a lot more than Native Image. It is also it also plugs in to the JIT compiler and able to improve your throughput by up to 20-30% and reduce latency. And it also has the truffle language framework, which allows you to seamlessly use multiple languages and binaries in a single application. So there's lots of exciting things in GraalVM. And Micronaut has a great relationship with GraalVM. Like I said, they're essentially a match made in heaven because of that closed world static analysis process, and the fact that Micronaut eliminates the need for reflection, runtime proxies, bytecode generation, and dynamic class loading. It means that the native image tool itself has a lot less to do to turn a Micronaut application into a native executable. And once you've done that, once you've turned your kind of Micronaut application into a native executable, the startup time is orders of magnitude better, and the memory consumption as well drops significantly, which is really great for cloud deployments, really great for serverless. If cold starts are a factor in your life in terms of planning on your serverless applications, Micronaut has great support for serverless. I think great support for things like AWS Lambda and Oracle Function and all the serverless platforms. And the drop in memory consumption means you can run a greater number of instances on the same hardware, which can lead to significant savings in terms of your cloud deployments. So the combination of Micronaut and GraalVM is really great, and they work really well together. Another important thing with Micronaut is the getting started experience. So you can today go to Micronaut launch, and in your browser at launch.micronaut.io or start.micronaut.io works as well. and it's accessible via curl as well. So there's nothing needed other than Micronaut launch to get going. You can choose your favorite build tool, your favorite testing framework, add all the features that you want, and basically generate an application today. And get started immediately. You can also like preview the application generation, and it's really neat. Okay, so with that, I'm going to actually start doing some demo. So I'm going to switch over to VS Code. And I'm going to be using today for this demo the Micronaut tools integration for VS Code. So if you want to try this out, what I recommend you do is you go to the marketplace, the VS Code marketplace, you install the GraalVM extension pack, this guy, and it'll give you the Micronaut tools that I'll be demoing today to create applications. So the nice thing about this is it integrates directly with Micronaut launch. I can basically select my Micronaut version, select what type of application I'm building. So like I said, Micronaut supports lots of different ways to build applications. So you can build, regular microservices, you can build command line applications, you can build serverless functions, you can build gRPC applications, you can build message-driven microservices. And in this case, I'm going to choose just the normal application. And what I'm going to do is I'm going to choose one of my GraalVM SDK that I want to use. And you can manage those through the extensions as well. And I'm going to create a new application called demo, private base package, choose my language. And here is where I can get to choose like some features. For example, I can choose, the Micronaut Data JDBC feature for doing database access. You can click OK, choose your build tool, Maven or Gradle, your test framework. In this case, I'll just go with JUnit. And then you can basically generate your application. So what I'm going to do is I'm going to create a new directory here called JNation and stick my demo application in here. And I'm going to trust this, and it's going to, since I just created it, it's definitely trustworthy. And I'm going to import the application into my IDE. So here we have a Micronaut application. So it's just a regular Java application. You've got a source main Java. You have a application class. The application class lets you run the application inside your IDE, and it's just popped up, as you can see. So I can actually click this and run the application from directly from my IDE to start trying out my application. You have a source test resources directory as well with a default test. And here we have an example of Micronaut test in action. So Micronaut test is a testing framework to test Micronaut applications, and you can immediately start basically running tests and so forth. So one of the things with Micronaut that you will notice significantly is how fast, for example, everything executes. So this is actually a full integration test that spins up the application. There's no mocking involved here, and it executes extremely quickly. That really impacts the development life cycle, because there's a lot of frameworks, functional tests take a long time to run, so people don't end up writing them. But with Micronaut, these execute so quickly that there's really no excuse anymore for writing good functional tests. It's really easy to do so. Other than that, we have a build.gradle. If I'd chosen Maven, there would be a pom.xml. More or less it's the same, where you define your dependencies. Configuration is provided through application.yaml. So because I chose the Micronaut Data JDBC feature, I already have some data source configuration in here. You can also come in here and, for example, configure the Micronaut port to be something else, and run my application on a completely different port and start that up. And this will essentially now my application will be starting up on port 8081, as you can see down there. So it's the IDE experience with VS Code is all integrated in terms of code completion and so forth. Now, for IntelliJ users, the JetBrains guys have done fantastic work on implementing the same features for Micronaut applications in IntelliJ. So you get the same kind of thing. You get like hovers for basically configuration and auto completion of different configuration properties and so forth. If I wanted to enable cores or whatever. So all of that is integrated. So the next thing I'm going to do is demonstrate is how easy it is to write a web controller and test it. So basically, I'm going to create, first of all, a new book controller here. So I'm going to create a new Java class called book controller. There it is. Okay, so here's my class. Okay, so and all you have to do is annotate this with app controller and your books endpoint. And then what I can do is add an endpoint that maps to the root URI and then list some books. For example, what I can do is to return arrays as list, understand The Shining, for example, and add the necessary imports here to fix those compilation errors. There we go. And I have added an import that lists some book titles. So to test this, let's write a test case. So I'm going to write a new test here, and it's going to be a book controller test. Like so. All we can do is we can make it a Micronaut test. And what I can do is, there's a few ways that I can test this. One of the easiest ways is with Micronaut's declarative HTTP client. So I can say, define a book client here that uses the client annotation as part of Micronaut and maps to the books endpoint. And I can say that it returns a list, returns some books, basically returning a list like that. And what I can do is in my test, I can basically inject that. So I can say test list books, and I can inject my book client like so. And we make sure that we import my test annotation, and then you can say client get books like that. Extract that into a local variable, which will be my results, and we can do assertions. Assert equals to results size. Okay, so add import for that. Let's run this test and see what happens. Okay, so it's executing and it has what has happened here. So let's see. Oh, I'm actually missing. So I'm calling get books, but I didn't define the actual HTTP method that I wanted in books. So in this case, I'm going to add the get annotation to say that I'm executing a HTTP get, and to my books URI. And let's run this again and see what happens. Okay, so now it's passing. The test is passing. So I can, also, write another assertion here that says results contains the stand, just to do like write a better test. And as you can see from this test that this is a full integration test. It's using the declarative HTTP client that is included as part of Micronaut to make a HTTP request to my locally running server. And it's really easy to write this integration test and really fast, really fast to execute. So you can, if you want, you can come into your log configuration and you can say, logger name equals io.micronaut.http.client and set the log trace level of the Micronaut HTTP client to trace. And if I come back and I run my application again, you'll see that I think I have to focus the debug console. You can see that I see the output from my HTTP client, sending the HTTP request, receiving the response with the different data coming back as JSON. And, it really was that easy to set up an HTTP client and HTTP server. Really trivial. Okay, so in this case, we're just sending back a list of strings. But one of the things that Micronaut, is obviously pretty common to send back JSON. So I'm going to create a new Java class that is represents my JSON model. So it's going to be called book. And I'm going to make a final field here, which is the title of the book, and another final field here, which is number of pages. And I'm going to generate a constructor for it, and some getters. So in Micronaut also supports Java 16 records. So with Java 16 records, you can just simplify this a whole bunch more by not having the getters, and so even slicker. But in this case, I'm demonstrating with Java 11. So I'm going to add a introspected annotation here, and what this does is tells Micronaut that basically informs Micronaut on how to serialize and deserialize. That this is a class that can be serialized and deserialized to JSON, without using a reflection. So you might say, like, why do I need an annotation for that? Well, one of the biggest security holes in Java applications today is like that arbitrary serialization of any Java object is allowed. So it's actually really good practice to say, this is a particular class that allows serialization and deserialization to JSON, and you can make this into a meta annotation if you want it associated with your code base. But essentially, what this says tells Micronaut it's going to generate the necessary metadata at build time, such that it knows how to read and write this book to and from JSON, or to and from the database, as we'll see later. So what I can do is I can come back here and alter this to instead return my books, like so. And now I can come to my test, and I can instead retrieve the results as books. And obviously this condition is now going to be deeply invalid. For the moment, I'll just comment that out. We'll write a better test later and run this and see what happens. So if I look at my debug console, you can see that now we have JSON coming back and forth with my data from my books, with the objects being serialized to JSON, and it's all working really nicely. So it's that easy to define an endpoint that exposes some JSON. And now let's see. The next step is, let's take this same application and turn it into a database application. So Micronaut supports has Micronaut data, which supports both a number of different ways to read and write SQL based database information. So it supports JDA, it supports direct JDBC. We have support for R2DBC as well for doing reactive database access. And in this case, we're using the blocking implementation, JDBC. In the case of blocking, you need to, because Micronaut is based on Netty, you need to tell it to run operations on a non-blocking thread pool. So what you can say is on the controller, say that this is going to be using task executors.io for all the operations to run in the IO thread pool. And what I can do here is I can change this entity to be a mapped entity. And in addition to my other properties, I'm going to add a ID property, and I'm going to make this ID a generated value, and that is the ID of the entity, like that. And I'm going to also generate a getter for that, like so. So now we have a way to retrieve the ID. I'm going to generate a constructor to add my additional constructor. And what I'm going to do as well is I'm going to, because essentially this the ID of an entity can, for example, be null if it hasn't yet been saved to the database. I'm going to mark that as nullable ID. And I'm going to denote this as the creator of my when I'm reading objects from the database. So when I'm reading objects from the database, this is going to be the creator that creates book entities from the database, and then I can use this constructor to essentially assign the ID to null when it's first created, and when we're saving new entities, essentially. And with that, I've got an entity that can be read and written to the database. So what I'm going to do is I'm going to set up some data for the database. So I'm going to come to my application class, and I'm going to make this application class a bean, because it isn't currently, by defining a bean defining annotation. So I'm going to make this a singleton bean that is going to listen for the startup event, like so. And I'm going to, in the constructor of the application, I'm going to want to write some data to the database. So when the application starts up, we want to write some data to the database. And in order to write data to the database, what we need is a repository. So I'm going to create a new Java class that is a interface, and it's going to be called book repository, like so. And we're going to make it extend from CRUD repository. And basically, CRUD repository has two generic arguments. One is the entity type, and the other one is the ID type. And I'm going to annotate this with JDBC repository with a particular dialect, in this case, H2, since I'm using H2 in-memory database. And then what I'm going to do is I'm going to inject this into my application class, like so, and generate a constructor for it, like so. And then what we can do is we can save some books. So we can use save all to save a whole bunch of books, and basically save all of these books that we were doing here. So we can basically do something like this to save all those books in one batch insert into the database. There we go. And with that, we can even annotate this method as @transactional to ensure that the operation runs in a transaction. In this case, it would have done anyway. But if I had multiple operations, I could make sure that all of those were run in the same transaction and roll back if any exception went wrong. And with that done, what I can then do is I can inject my book repository into my controller, like so. And what I can do is alter this method to call repository.findAll. And this will essentially, the findAll method by default, I believe, no, that's definitely, actually returns iterable. So in order to make it return a list, we can instead source actions, override method, find all, and we can make this find all method return, which by default is inherited from the parent CRUD repository interface. So CRUD repository provides a whole bunch of methods, this parent interface, that allows you to read and write data from the database. And one of them is called find all, but there's also like save, which I used before, and save all, which I was using to persist everything, update all, find by ID, a whole bunch of useful methods that get inherited by default. So I'm going to call find all, which I've overridden. And hopefully this demo will work in terms of the results coming back from the database and everything working as anticipated. We'll see if the demo gods are with me, which they appear to be. So if we look at the result now, you can see instead of if we look at this, output, you have database IDs coming back from the database. So I've written a like full database application in the space of just 10 minutes or so. Now, one of the cool things about Micronaut data is it's really cool, and Micronaut in general is all the compilation time type checking. So, for example, if I wanted to add another endpoint here, that found a book by title, I could create a URI variable, and create a find method here, and find something by the title, and I could add a method here called find by title, like so, to perform the query. And obviously that method actually doesn't exist, so I can create it, and I can switch over to my repository here, and there's my find by title method. So that's how simple it is to implement some kind of basic query or finding a particular book by title. Now, one of the nice things about Micronaut as a compilation time-based framework is the active type checking. So, for example, if I were to misspell this parameter like this, for example, you can see that I get an error saying the root declares a URI variable called title, but no corresponding method argument is present. So this is like active type checking that integrates with the Java compiler to ensure that you're using the framework in the correct way. A lot of feedback that people have given regarding, annotation-based programming models are the fact that it's, less type safe or more stringy based because of the annotations. Well, that's not the case with Micronaut because we have active type checking of the data defined within the annotation and how that maps to parameters and so forth. And the same thing happens with Micronaut data. So this find by title method, which is just one query method of many that are possible. For example, you can say find by title and pages greater than and there's a whole expression language for Micronaut data in terms of defining queries, very much like GraalVM, which was the original implementation in the Java world, or from Grails or Spring Data or so forth. But with Micronaut data, you can do things. If I, for example, in this case, I'm querying the title property of the book, right? So this book class has a title property. But if you try to query some other property that doesn't exist, again, we get active type checking through the compiler saying, you're trying to write a query for something that's not possible. So don't even bother compiling, rather than letting the application start, letting the application fail at runtime, you having to debug what's going on, or where's my typo. The framework is handling that for you in terms of active type checking of what's going on. So that's one of the really cool things about Micronaut. And of course, this application is already fully baked in terms of being a little database application. What you can do is very easily drop into terminal, for example, and I can build it using GraalVM assemble. Or if I was using Maven, I could use Maven package, and that would, I would and package it up into a runnable jar file. So I can say jar build libs, all to run the application as a runnable jar file. I can also do build a native image. So you can actually do that from the IDE via Micronaut build native image, which will essentially, build a native image via the IDE. I can equally do that via terminal. So anyway, if I just run it via the IDE, you'll see that we can build the application into a native GraalVM executable and benefit from that, super fast startup time and execution performance and so on and so forth. So while that native image is building, I will just go on and continue with the presentation. Because building a native image takes a little bit of time. So Micronaut project is really healthy. It's actively developed by a variety of engineers. We've had contributions directly from Google employees, object computing, Oracle computers, Oracle as well. Currently, Oracle employs 5 engineers working on the Micronaut project, has over 289 contributors, 5K stars on GitHub, 10K commits. We're working actively on Micronaut 3 right now, which is going to be the next big release. And do start the repository. And who knows if you are the 5,000th person to start the repository, because I think we're very close to 5K. We're just under it. You might get a prize or something. Who knows? So do go and star us and follow us. Micronaut has a lot of activity, and also on Gitter, on our Gitter chat channel, we have well over 2,000 people hanging out there, asking questions, participating in the community. So do get involved. So in terms of summary, Micronaut and GraalVM are leading this revolution of ahead of time compilation. And server-side Java in general is adapting to things like serverless, things like low memory footprint cloud native microservices that run in containers. And with AOT, you do sacrifice build speed and so forth, but you gain the ability to take Java places where it wasn't even possible to take Java before, right? With native image, you can use Java for IoT applications or on mobile or super low memory microservices, places that people wouldn't have considered using Java before. It's possible today with native image, and it's a reality today thanks to GraalVM native image. So let's switch back to code and see. Oh, my native image finished building, and with this completed build of the native executable, you can see that startup time, even though that I'm using a database and writing to it on startup, is 30 milliseconds, which is just significantly faster than anything the Java version would be able to put out. And memory consumption as well. I don't know with memory with whether you're able to see that, but basically 20 megabyte of memory being consumed by that native application, which is significantly smaller than the Java application would have been able to consume. Okay, so with that, I have time. There's some Micronaut resources here. So we have the Gitter community, the user guide. You can create applications with Micronaut launch. We have some great guides. Do follow us on Twitter. Do connect with us and star us on GitHub. And with that, I probably have time for some questions, I hope.
Hello, Graeme.
Yes.
I mean, wonderful presentation as always. I expected as you, right? I really love to see your stuff, and you really demonstrated some really cool stuff. So I'm pretty sure our audience is really happy about it. Yes, I mean, we don't really have not that many questions, and we have a couple of comments saying it was a joy to see some of Micronaut again, right? So I think that we've seen like Micronaut has been a long way from the first couple of things that we saw. Now it's so cool to see it so much evolve with so many new cool stuff. So
Yeah.
really happy. I think the users are really happy and the viewers are really happy about what you demonstrated over here. And I'm pretty sure that we can expect for Micronaut to keep evolving and becoming even better.
Yeah, absolutely. We're moving towards more standardization coming up soon. Micronaut 3 is going to be released in summer, and we're really excited about that. Lots of innovation happening there, with new features like constructor injection and the ability to define beans at build time and additional beans and so forth. And a lot of the fundamental APIs to support the CDI Lite effort, which I'm involved in, is going into that release. So it's going to be an exciting year for Micronaut and GraalVM progress this year. So it's a good time to try it out.
Wonderful. So we pretty much out of time, and but anyway, if you come up with any questions later, I'm pretty sure that you can reach up Graeme on Twitter. I know that he's very happy to answer them over there because he's super active on Twitter. So Graeme, I'm gonna let you go. So thank you so much for joining us today, and hope we can catch up later, or at least physically at some time
I hope
in
so
the near
too.
future.
That would be great.
Yeah,
Definitely be good. Looking forward to the return of physical events for sure.
definitely. Okay, Graeme. Bye bye.